Welcome back, everybody. So this is section 9.2, linear regression. This is something that you've been doing since Algebra 1, probably. Well, if you had honors Algebra 1, you may have done it in there, but definitely honors Algebra 2. And I believe even regular Algebra 2 does linear regressions at least. Now, I think I'm going to, maybe on the day we get back, we're going to do one of these by hand, just as a fun in-class activity. Fun. Because we got an extra day, why not? I thought, hey, that'll be a good first thing to do when we get back from Thanksgiving.
Free day.
Just as a reminder, we do have our quiz on Tuesday of next week. That is over chapter 9. Okay. And again, if you know you're going to be gone on Tuesday, I would highly advise you to take it Monday. Just saying. All right, so let's take a look here. Linear regression. Once you have determined that the linear correlation between two variables is significant,
Interruption. At this time, varsity cheerleaders that are still in class, please report to the gym now.
the announcements that happen on days like these are just like,
why did they do it at 8:30? That's like a whole hour before.
what are those people doing? Like, what prep do they need?
She said, please.
Well, they came back
to your gym.
because they said they got called down too early.
Really?
Yeah, like all the cheerleaders came back to classes.
What?
Oh,
Dang.
oh.
Wow, Will. Good
Good
job.
Name and names?
Call them out.
That's
In the video.
In the video. So again, we have our quiz on Tuesday, but so Monday we will be reviewing. All right, once we have determined that the linear correlation between two variables is significant, we then want to find the best line to fit that data. The difference between those observed y values and the predicted y values are called residuals. Back when I teach linear regression, I never taught the term residuals. That is actually in the Algebra 1 curriculum now. Like, I have to teach my Algebra 1 students about residuals. A residual is basically the amount left over after I take my predicted y value subtracted away from my actual y value. What I mean by that is I'm going to make a line of best fit, and then I'm going to have an x and y pair. Well, the x value is going to correspond to a place on the line, but it's also going to correspond to a piece of data. The difference away from the observed y value and my predicted y value is called a residual. A regression line basically just tries to make those residuals as close to zero as I possibly can get. Okay? That's what the line of best fit does. That's what a regression line does. It tries to take those residuals and makes them be a minimum amount, right? That's what it does. It takes those residual values and forces it to be as small as it possibly can. A regression line, also called the line of best fit, is the line for which the sum of the squares of the residuals is a minimum. The sum of the squares of the residuals is a minimum. They use the sum of the squares as a minimum. That's kind of just like amplifying the residual, right? But it's really just when you square a number, you amplify the deviation away from that value. So that means in this case, the sum of the squares of that is just kind of like amplifying the residual amount and finding the smallest it could possibly be for that. Okay. As a diagram, just to show you, the book had this diagram, which I really like. I'll just pull it over onto this page because I still saw some people writing. It's hard to kind of visualize residuals, and I think this diagram does a pretty good job of it. Say we had this scatter plot here at D1, D2, D3, D4, D5, and so on, whatever. And I had this scatter plot here and all these points out here in space. I have this predicted y value, this line. And then I can calculate the y values that should end up on that line, right? But I also have coordinates that are a piece of data. Like there's this piece of data, D1 here, and I can see that it's a certain distance away from the actual line of best fit. So what we're doing here is taking these residual values, and they're different size for each piece, taking those residual values and finding the minimum that they could possibly be. Okay. the sum of squares of the residual values, and then making that as small as it could possibly be. It's important that we do take the square though, because some are going to be above the line and some are going to be below the line, right? So we're kind of like taking out any possibility of having a positive versus negative effect to it. Okay, now I'm going to show you how to do this in your calculator, but again, we might do it by hand one time. Why not? I don't know. But our equation of the regression line is going to be y is equal to mx plus b. It's going to come out in that mx plus b form. But I want to show you exactly what your calculator is doing for you. Oh yeah, we're going to do that one time. Yes, we are. Yes, we are.
Like as a class or?
Yeah, we'll do it together in class. Not on the assessment.
What day are we doing this?
I'll surprise you. I'll surprise you. What a treat that would be.
Over here all
You
night.
said they when we get back from break, right?
I don't know. Maybe.
Okay.
We'll see.
I'll be here.
I'm
Is this
skipping.
gonna be like?
I just think you only have a certain amount of days left in this class, even.
Is this gonna be like bonus points?
Ooh, maybe. Ooh.
Don't give any
Don't
ideas.
jump
Why?
So.
If it's a bonus
Bonus
point,
points,
if it's a bonus
why
point,
are you
you
don't
have
have
to
to do it?
Tell me you're memorizing that.
If
and
it's a bonus question, it's fine.
I'll give you the formula.
Oh, for real?
Yeah, why not? You get the formula sheets. But let's analyze what each piece is. So the slope, just to find the slope, you take the amount of pieces of data you have and multiply that by the sum of all of your x times y's, right? So you're taking all of your x times y. You're pairing up x and y together, and you multiply them together, and then you're going to add up that whole column, multiply by n. You're going to subtract that away from the sum of the x's times the sum of the y's. Now that's different from saying sum of x times y. You're taking sum of the x's times the sum of the y's, and you're going to subtract those two values. On the denominator, this is kind of like the slope formula, really. Y minus y, piece minus piece over piece minus piece here. And the n times the sum of the x's squared, and then you're taking the sum of the x's squared. Okay, this is the sum of the x squareds minus the sum of the x's squared. Yeah, so you notice the pieces on y up top, y's divided by x's for our slope. Then to find my b value, I take the sum of the y's divided by n minus m times the sum of the x's divided by n. That's kind of like taking the average y value and the average x value and making your equation, kind of like doing slope-intercept form to solve for b. Yeah, you just find your average y value, you find your average x value, and you use that coordinate along with the slope that you came up with to find your equation. So let's do it in our calculators instead, shall we? Because that's way easier. Let's put this data into our calculator. Remember, to do this, we go stat, edit. I'm going to clear out everything that's there. And we have, this is gross domestic product and carbon dioxide emissions, right? GDP and carbon dioxide emissions. What do you think is going to happen as I increase GDP? Carbon emissions is going to do what? It's going to increase, right? The more our, the higher the GDP, probably I would guess that the carbon emissions is going to go up. More factories and stuff working. 1.8. And pieces of data. Oh, 11:57. Okay, I got to spot check this because sometimes double numbers don't come through. 441.9, 262.3, 232 point nothing, 240.5, 742.3, 544, 434.2, 604.4, 1.3, 2.4, 1.53, 9, 1.43. Okay, cool. So I go back out to my home screen and I go stat, calc, 4, linear regression. It's going to be in that AX plus B form.
You're still here.
Yeah, I think they're going to call you guys down.
No, he said to watch for the time because they're not calling announcements.
I
And put the email if you want.
Yeah, let me look at it. No, I got it. They sent us an email too.
Oh,
I hope that your house isn't frozen.
Okay, yeah, go ahead on that. I mean, it's 9:10 anyway, whatever.
Alright.
Make sure you watch the video. Alright.
Was she in it? Oh.
Yeah.
Yeah.
Okay, AX plus B. So here is our linear regression, right? Here's our linear regression. So we see that it is y is equal to 199.53x plus 56.04. Okay, what does our R value tell us? What does our R value tell us? Yeah, strong positive correlation. Yeah, just as we suspected, as GDP is going to increase, carbon emissions is also going to increase. Right? Okay. Use this equation to predict the expected carbon dioxide emissions for the following gross domestic products. Now, I want to show you how to find X values super easy and very exact. Now, please follow along here, because this part gets a little tricky. I want to put my regression line on my calculator. Okay, and here's how we do so. Everybody hit your y equals. Make sure your plot is turned on. Now we're going to put the regression line into our y equals. And here's how we do that. Everybody hit VARS. V-A-R-S. Scroll down until you see statistics. Hit enter. And then scroll right twice to EQ. Again, that was VARS, statistics, and then to EQ. That put, and you have to start in your y equals. Okay, you have to start in your y equals. Now, hit zoom, stat, and you should see not only your scatter plot, but also the regression line come through. And now at this point, you can calculate any value you want for X. And it's exact too. Like, look at your regression line that went in. It went into the nearest, like, how many, 10, 11 decimal points? We rounded to the nearest 100 when we wrote it out. So go to your graph. Now I'm going to calculate $1.2 trillion for the GDP to figure out what the expected carbon emissions would be. So I'm going to second calculate above trace, and then I'm just going to hit value, 1.2. And then the Y value is the expected carbon emissions. So here's my 1.2. I'm going to do the same thing with 2.0. Second calculate value of 2. I'm going to do the same thing with 2.6. See, I didn't even need to run any calculations there. That was hardly any work for me to do those three. And the nice thing is that now, if I wanted to, I could find a y value as well, right? I could say, or I'm sorry, I could find an x value given a y value. I could say, well, what if I knew a certain country's carbon emissions? Could I estimate their GDP? If I knew their carbon emissions, could I estimate their GDP? Like, what if their carbon emissions was 305 millions of metric tons? 305. Well, the y value is 305. Now, to do so, you would go y equals and put in your 305. Graph it, and you'd see a horizontal line coming across. And I find my intersection point. I second calculate. Intersection is choice 5, and I just hit enter, enter, enter. So if I know a country's carbon emissions was 305, I could estimate their GDP to be 1.25 trillion. I could do the same thing. What if I had said, well, maybe it's really high. Maybe it's like 1,000. I just got to make sure that that value comes out on the screen. Yeah, the intersection point's on the screen. Perfect. Second, calculate the intersection now. So if their carbon emissions was 1,000, I would say that their GDP is $4.73 trillion. So given an x value, you can find a y value. Given a y value, find an x value. All right, that's all we got. That's it. That's everything.
Oh, wait, that's it.
That's it.
The homework, right? I think
Homework's
we-
right here.
I think we understand it. We don't need homework.
Yeah, honestly,
Look.
this is very
Three
simple.
problems too many.
Yeah.
Bro, how long has it been doing that?
We all know how to do
Do
this.
you have the